Well, hello, everybody. I want to welcome everybody to this fantastic opportunity to learn about combined heat and power from one of the people who helped design the German combined heat and power policy, Jens Acker. He is brand new to the United States. He just started his job at the German embassy in Washington about 6 weeks ago. Before that, he was in the Ministry for Economic Affairs and Energy. And his contact with renewable energy in a professional way started in 2011, right after the nuclear accident in Fukushima. He's a trained lawyer, and he had been working on all kinds of projects. The German government, because of the energy transition, needed expertise from a lawyer's perspective with all of those changes, and that's where he came into the picture. I'm really excited that he is here and that he is making Minnesota his first official visit. We're very grateful to him. As he told me yesterday after I picked him up at the airport and asked him, have you been to Minnesota? What do you know about Minnesota? He said, never been here, but I closely missed it when I was a high school student, because my city in North Rhine-Westphalia has a partnership with a city in Minnesota. I was very curious. And then he says, wouldn't you know, White Bear Lake. So we're very happy that we have somebody here who is always meant to be here, but now he's finally here. We hope that the talk that you're going to hear today and the conversation you're going to have with him today will bring you back. As I'm looking around the room, I see there are lots of people from outside the university. By the way, if you haven't picked up a program yet, there's a little program that has everybody's contact information. What we're trying to do here at the University of Minnesota and the Institute on the Environment with this project is to bring people together on renewable energy issues, integrated systems thinking. It's a project that is co-funded by the German government, and we are gearing up to making this a larger conversation platform. With that, I would like to turn things over to Ellen Anderson from the Energy Transition Lab, who is one of the co-sponsors of this talk. Other co-sponsors in the university to thank are the College for Science and Engineering. Ellen? If you can just say a few sentences about the Energy Transition Lab.
Thank you so much. So, and hello, it's a pleasure. Hi, I apologize for walking in late. So I'm Ellen Anderson, Executive Director of the Energy Transition Lab, which is a university program affiliated with the Institute on the Environment and the Law School and other interdisciplinary aspects of the university from far to wide. And we work on a variety of different kinds of collaborative energy transition related projects. And I've always loved the name Energy Transition Lab. I didn't create it myself. Professor Hari Asofsky, who founded the lab, did that. And I like the parallel with the German Energiewende, which is a real model that we in Minnesota have been lucky enough to learn from. Many of us who have had an opportunity to go and witness and study the progress that Germany has made and the leadership that they've shown that's affected the whole world's markets in energy and development of policy. So it's very exciting. On the topic of combined heat and power, who's here? Is there anyone here from the State Department of Commerce? Well, Will Seifert from the Environmental Quality Board, but I should point out that the State Department of Commerce, the Division of Energy Resources, has had a very robust process over the last few years, a stakeholder process that's engaged probably some of you in this room to evaluate opportunities and barriers and pathways to combine heat and power in Minnesota. And so there's a lot of really good information available on their website if you want to learn more about what Minnesota is thinking about how to advance combined heat and power as a great energy alternative and opportunity for our state. So with that, thank you so much for giving me the opportunity to say hello, Sabina. And do I pass it on?
Yeah, I have one.
Acker.
Yeah,
Okay.
okay.
Very good.
Yeah, thank you very much for Sabine for introduction, and thank you very much for inviting me here. I just learned that there are very many people here that already know a lot about energy, about CHP, so which I was not really prepared to. I prepared some slides which are in some parts very basic, so please don't hesitate if you have questions or say you know all of that and hurry on. Please tell me that. As Sabine said, I'm a lawyer from profession. I've been working for the German administration on different levels. I started my career 17 years ago, it is already, on state region level in the land of Saxony. I've been working there on structural funds spending. Later I switched to the federal side, and I've been working for the past 10 years or so in the Ministry of Economics and Energy, in the last 6 years on energy issues. As Sabine said, it was very exciting in Germany after Fukushima, and our government made all these decisions about getting out of nuclear power, getting more forced into renewable energy. It was clear that we would need a bigger energy department, so they gathered a lot of lawyers there, and one of them was me, and it were really exciting times, I can tell you. I've been focusing on security of supply issues mostly, and for the last 3 years on CHP. Actually, last year the parliament passed a novel of the CHP Act. I'm going to talk a little bit about that, about the political framework for CHP in Germany later on, which was a very interesting discussion. A lot of things that I'm going to tell to you about are taken from this discussion. So we get started. Short outline, very, very short history on district heating and CHP, a little bit about CHP and district heating, what it is all about, state of play in Germany, where do we stand, what are the challenges of the future. There I'm going to elaborate a little bit on the discussion. What is the role, or what can be the role of CHP in a more and more decarbonized world with more and more renewable energies? Very interesting. And then I'm going to work really on CHP and renewables, which was at the core of the political and technical debate also. Then I'm going to present you some of the ideas of the utilities, how they think, what their place can be with their assets in this new world with a high share of renewables. And at the end, I tell you what politics thought about what can it be. It was a little bit of a compromise, as you might assume. Very short history. People also already in ancient Rome detected that it is more useful or very comfortable not to heat something in your rooms, to have all this steam and everything in your living room. And they used thermal water, which has been transported to cities to heat up their dwellings. Of course, it was limited to a very small number of people who could take advantage of that. In France, there is a proven system of district heating, also using thermal water in the Middle Ages. And actually, the first modern district heating system has been set up. A lot of you might know that in the United States, in Lockport, state of New York, where this man that I didn't know until recently, Holly, detected that while you have a steam engine and you have this hot steam, hot water, why don't you use it for something else? Actually, that was an offset from industrialization, the age of the steam engine, where you used this hot steam to generate something, mechanical energy, later electricity. And you had the steam, and was in cold areas, New York, or later in Europe also. They thought, what can we do? And so they took the heat, used a pipe system to bring this heat into the dwellings. Later, they started combining this. This is the link to CHP, so combined heat and power also. When electricity took ground, first electrical systems in New York City, for example. And this man, Mr. Holly, he sold actually, he had intellectual property on that, a patent on it, and he sold it to New York, and they set up a system of combined heat and power with that. In Germany, actually, in the 1980s, 1990s, the first, all through Europe that happened with industrialization, these systems picked up a little bit. And the first appliances were in hospitals, yeah, where the doctor said it's not good, it's not healthy to have a single heating in the rooms where sick people are, where you have all these ashes, all the steam. Please get rid of all of this, take the generating of heat and power out of the rooms where the sick people are, and they set up systems. Actually, when you get to go to Berlin, there's one place, it's called Belitzer Heilstätten, which is a huge sanatory built for 500 people that the Kaiser at the time has built for sick labor force. Tuberculosis was really an issue at that time. There was one of the first district heating systems have been set up there. Yeah, but not only in Berlin, in Denmark, Copenhagen, and in Great Britain, and other parts of Europe and the United States as well. This doesn't work. Yeah, this to show you, this is an advertisement for the first district heating system of Mr. Holly. That actually it tells you what CHP district heating is all about. It says, it's hard to read, Mr. Manager, why are you throwing away the exhaust steam from your engine when people are willing to pay you 3 times it costs of production for heating purposes? And it goes on like that. So it tells you, you have the steam, yeah, you're about to use it for something anyhow, and there's steam left after the process, and please use it. And that tells you where the efficiency of the CHP process comes from. This is a little bit elaborate way to say the same thing. You have 100% input from coal, a piece of coal, some gas or something else, some biomass that you burn. And how much energy do you get out of it? The degree of efficiency of CHP is superior to heat only and to to electricity only generation. A modern CCGT combined a gas turbine gets up to 60%, 63% under perfect conditions. So if you put 100% primary energy in, you get 60% out of it, 40% are at loss. If you use hard coal or lignite for that, the losses are even higher. If you use combine a CHP plant, a CHP unit, you take a little bit of the steam out of the turbine, so your electricity efficiency will drop a little bit, but the overall efficiency will be bigger than a separate heat-only and electricity-only production. That is actually what the whole idea of CHP is about. Yeah, it's just in other words. In Europe, we have a directive which sets a standard for high efficiency. It comes from a different side. It defines high efficiency cogeneration, at least 10% primary energy savings compared with the reference. And the reference is separate production of heat and electricity. The standard is important for funding schemes. So in Europe, we agreed on you can only give subsidies to these kind of generation, which everyone in the northern part of Europe does, if it is high efficiency cogeneration. And that's a 10% savings, which is not very much. No? In most cases, you will get much more savings, but this was a little bit of the compromise because you have different weather and climate conditions, and not everybody could comply with the more severe standards. Yeah. What can you use to fuel your CHP unit? You can use coal, natural gas, digester gas, biomass in general. All this can be used. The technology actually are turbines and motors. Yeah, just a standard thing. And you put into, as a fuel, all these primary energy. But, and this is important for maybe for future times, when you have a district heating system, a public system, you can also use other sources of heat because your main asset is a district heating network. And it's not important where the heat is coming from, if it is a thermal unit where you burn something actually. If you have a geothermal source somewhere, you can use that. For example, the city of Munich in southern Germany has the goal, set the goal to be 100% carbon-free by 2040. Munich first is a very rich city, and the utility is also very rich, and they're sitting on top of a geothermal source, and they want to do a combination of geothermal heating of their district heating system and biomass cogeneration. There's already one plant in use, which is a little bit older, and they plan to hook up. They're drilling now. They do the drilling right now. Yeah, you have different areas where CHP can be applied. Actually, we said there are three basic areas. The biggest one in Germany is the district heating sector. These are the big, dense agglomerations. It's Berlin, Hamburg, which do have the largest district heating networks. The Ruhr area, where I'm native from Essen, Dortmund, Bochum, 6 million people living there. Mannheim, it's an area a little bit close to Frankfurt. A lot of industry there, a lot of people living there. And Munich, it's not quite as big, but in the south, it's a little bit harder. Yeah. There you have these large district heating networks. The second appliance field for applying CHP is the industry. Yeah? And it's completely different there. It's a different pattern of running a CHP unit in the industry. It's chemical industry, it's paper mills. In Germany, it's partly car manufacturing, but mostly is paper and chemical industry. Then the third area, it's a little bit diverse. We have heating for individual houses, for some blocks, for new build blocks, for example. It might make sense for a small community who's growing and to say we have a greenfield investment here. We do have houses. How do we get an efficient heating system there? So you might set up a CHP unit there and have a small district heating network. It's a little bit different from the big municipality owned things there. Then you have, for example, in services, they are used very often. Supermarkets who have cooling, for cooling, you can heating and cooling, use CHP for heating and cooling. Internet server things, for example, and also single units like housing for older people where it has to be warm, constantly warm all day long, or where you have a public swimming pool or something like that, where you have a constant demand of heat over a longer time. This is where CHP really makes sense because you have to produce this heat anyhow, so why not produce energy, power at the same time? Yeah, state of play in Germany, 16%, which is roughly 100 terawatt hour of the net electricity production in Germany comes from CHP units, was last year. The share of district heating in the heating market is about 13%. So you see it's not terribly big. And it's a thing that politics are concerned about and are working on. It saves up to more than 50 million tons of CO2, which is one thing for good, but it's also important to notice that it is a way to get other emissions out of the city centers. Yeah? Historically you had these coal firing in your individual houses, and so that it produced a lot of ashes and dirt, and you wanted to get them out of there. So you produced a district heating network and had just one plant at a certain distance from the cities where all this was produced. In Germany, the fuel that is mostly used for CHP is gas in district heating and industry. We have a share of 20% is produced by coal, 15 hard coal and 5 lignite. Usually these are large, the classical large 1 gigawatt, a little bit gigawatt power plants where they take a little bit of the steam and use it for whatever, for district heating systems. It's not really so important. As concerns where it is applied, 50% of CHP is used in in these agglomerations, big cities, district heating systems, and 30% is industry. The rest, quite important, is also CHP from biomass, which is mostly deployed on the countryside, which picked up enormously because we've been giving subsidies to a large extent to that. It picked up from almost zero 15 years ago to 12 to 14% of the CHP, with 12 terawatt hours about that. It was quite important also for agricultural sector, of course, because it's a new stream of income there, but is politically also a little bit contested. I heard you have a little bit of these discussions about biomass, using biomass for CHP here also. Yeah, what are the challenges of the future? As I said, last year we had a major reform of our CHP Act. The CHP Act, it says subsidies giving to CHP plants. I'm going to explain a little bit later about the details. And when we started the political discussion, there were people saying, well, we're heading towards a green world with more and more renewables, intermittent renewables in there. For CHP, of course, it's efficient, but it's still fossil fuel being burned there. This is not a lock-in investment, was a key word, lock-in investment. We invest now in a power plant that's going to be there for the next 30, 40, 50 years, and it's going to produce CO2. Is this not premature? Shall we not just take the next step and have an all-green energy system? And other people said, oh, well, we're not that far yet, and we still don't have solutions for certain parts of an all-green system, and we will need thermal generation for certain purposes in the system, in a power grid, for example, to keep it stable, frequency and voltage and things like that. So the last, that was a key word, sentence was the last fossil fuel-fired power plant that is shut down has to be a CHP plant because it's the most efficient one. That was the other perspective on that. Yeah. But then people said, well, okay, that might be true, but are they flexible enough? Because we have these intermittent renewables which kick in the electricity system, and the idea is to appreciate the advantages of that and not to kick them out because you have a must-run unit, CHP, that is not flexible enough to get out if there's a storm front in the North Sea and we have all this wind power pressing into our electricity grid. And I'm going to work on that a little bit later on. The answer is CHP units are pretty flexible in some regards, especially in the public sector, yeah, because there we have flexibility options, a new keyword also. Industry is a little bit different, but on the other hand, people said, look, what is the German business case? We have energy, high energy intensive industry, which is at the core of our economy, actually, and as long as we have this, we need this heat, yeah, and we need this heat for our production processes. We have to produce it somehow, and until now, nobody came up with a solution to produce it all in an all-green way. But there was a question, yeah.
You've used the word flexible a few times here, and as an attorney, I appreciate your comments on the flexibility of your permitting agencies, and I'll give you the context where I'm coming from.
Okay.
I work with a few dozen biofuel producers in Minnesota, and for them to be productive and have the lowest carbon intensity fuel, they continually need to evolve. And that means bringing in new technology and new processes. What we find, though, more often than not, I don't know if anybody from the Pollution Control Agency is here, but when there's an opportunity to insert a new piece of technology, it's blocked. So to drive down carbon emissions, to drive down the NOx, to drive down the criteria pollutants, we could make tremendous strides, but the permitting process actually is so antiquated that we're unable to be flexible. And I'm just wondering how the German industry and power producers come together to actually make change happen. Okay.
Yeah, just very briefly, we can talk afterwards more in detail about that. I mean, if you talk to German companies, for example, they certainly will complain about the lack of flexibility and administration, and also of grid operators. Grid operators are the most important part in that. We have constantly these issues about how can a small CHP unit, for example, in the countryside be hooked up to the power grid. System operator might say this is not safe enough, I cannot rely on it. Well, actually, I believe that these processes have been established now. We've had these discussions over the last 10, 15 years. What are the criteria for TSO to reject really a small CHP unit in the grid because it's not safe? He has to define it's not safe. There's standards, they have to be met. There's still, there's still some complaints about it's not fast enough. So but maybe we can get later on that, yeah?
I've worked on several CHP units. The flexibility of power production, we can't cut back 50%. We have to maintain at least 50% of max power. We usually run at max power.
Okay.
What are you doing in Germany? What kind of flexibility do you have?
Well, as I said, I'm not a technician, but I believe they can go below. They can again be below 50%. It's not good for the business case, of course, and it's not good for the motor, because if you constantly keep it running up and down, it might hurt the engine at some time. But that's also a technical issue. That maybe you must invest in more solid motors at that time, or turbines. But maybe we can get later on to that. Did I cover everything? Yeah, flexibility. Are they flexible enough? I mean, motors and turbines can go up and down. Yeah, the issue is what do you do with the heat? And technically, how good are the motors? Well, if you talk to the producers of the machines, they say they can do a lot of things with that, but it's an issue of the price, yeah, and what they use to put in there. So a little bit to the background. Germany, as you know, has a very ambitious, started a very ambitious process, not only after Fukushima, actually started much before that, but after Fukushima it became such a momentum, such a speed, that it is really changing the complete power system, the power system completely. This is a little bit of our goals. The goal for 2020 is a share of 35% renewables in the power system. Last fall we were above 32%. You might have heard it one or the other. A couple of weeks ago, it was a sunny Sunday with no industry in the grid, very low load, and sun was high, a lot of wind in the North Sea, and we covered above 90% in the grid. So grid stability was kept. We always have to say this is Himmelfahrt. This is what we say Himmelfahrt here. It was a holiday, so though they had basically no industry in the grid, the load was very low, and so it's easy to get up to that 90%. But for the TSOs, this is a big day because they know it's happening. Every year it's happening that day. Himmelfahrt, you might look that word later on. It's usually very sunny, and at that day it was very windy at the coast, so we had a lot of renewable energy in the system, which is an extreme situation. Let's not be kidding about that. For TSOs, this is really a challenge to cope with that. These are technical issues, but they have to be taken care of. Yeah. So this was happened between 2000 and 2013. Now it looks a little bit the same. All the red and green dots are renewable power plants, wind, solar, biomass. You see in 2000 we didn't have any solar at all. In 2013 is lots of PV. Actually funny for a country like Germany. I learned that Minneapolis is at the height of Florence in Italy. For German, this is hard. It's very warm, sunny, and so we're not really particularly known for having very warm summers and lots of sun. In the south more than the north. But actually what happened was a combination of a very good subvention scheme, the Renewable Energies Act, which was very reliable, which everybody knew, and a progress in industrial production of solar panels. The Chinese kicked in the market at around that time and brought down prices tremendously. And there was a funny thing that happened in 2008, 2009, the big financial crisis in Southern Europe, where they had set up also these subsidy programs. They cut them from one day to another because they had other problems. They say we spend our money on other things. So all the solar panels that had been produced and shipped to Italy and Spain turned around and went to the only market left with a reliable subvention scheme, that was Germany. So practically overnight, the prices for solar panels came down, and it was a real bonanza. I remember it was on New Year's Eve in 2013, 11 or something. It was in North Germany. It was freezing cold, and there were people nailing solar panels to the rooftop because the next day there was the feed-in tariff declined. So they said, oh, well, get them up there. So. But I mean, the tariff was too high, and we were too slow in cutting them down. There was a lot of mistakes that occurred there politically also. Yeah, and 2025 we will have more solar and especially more wind, because what happened next was that the wind industry, wind generating industry, detected the business case. It took a little bit longer because it's heavy machinery. You have to build up a line to produce that, and it takes a longer time to have it installed. We have also very ambitious and very costly plans for offshore generation. We have the first offshore big parks in the North Sea and in the East and in the Baltic Sea. They're going to produce big time because they go up to 4,000, 4,500 operating hours a year. Onshore you get 3,000, and in the south even less, so the business case is different. This is really a revolution in the German power system. Yeah. Where is CHP in all this? Ah, yeah, okay. Yeah, I mean, the issue is if you have politically driven more and more intermittent renewables in the system, there's less space left for the rest of it, for conventional power generation. And just these are, it looks very complicated, you forget about it, but I just want to show that, that the changes that are happening in the system. This is winter 2015. These are actual slides I took from Fraunhofer, but they took it from the TSOs. There's a little bit the changing world. You have hydropower in the base, you have biomass, it's just running like that. You still have the nukes running down there, and lignite in Germany, very important, 2 areas. So a little bit uncomfortable it gets for hard coal, because this is here like the merit order of the cost of generation. So these are the cheapest energy is down here, and the more expensive is up there. And for hard coal, it's getting uncomfortable, because above there are the renewables which keep cutting in the place where used to be conventional power generation. And actually, the one which is the most under pressure is gas. Might surprise you, because in the United States you have a different situation. Gas with a fracking boom, and cheap gas became cheaper than coal, which is changing the American power system a lot. But in Germany it's the other way around. We have hard coal, which comes not from Germany but mostly from international market. We have lignite, which is from Germany, it's just there. And gas comes from Russia. Yeah, from now a little bit with LNG from the States also, but it's fairly expensive, yeah, to burn it, to produce electricity. So renewables cut in there. This is a winter week, so you don't have the solar yet, and winter is not particularly a very windy time. We have the wind usually in fall and spring, like in other parts of the world also. This is a summer week. It looks a little bit more dramatic, and this was last May. A week there, and now I'll show you what happens, or what might happen, or is expected to happen in 7 years or 6 years now. So the space where it can be used by conventional power plants is getting smaller and smaller, and especially in the summer. Yeah? So there's not much place left for CHP. Issue of flexibility, are they able to cope with that, yeah? To go up and down, and is it really good? Do they lose their efficiency gains that a usually running CHP power plant has? Does it lose it if it is doing that, following the pattern of renewable energy? Yeah, and this is I took that from research work. The green is shown what is left in 2050 with 90% renewables. So the gray is the load, is covered by renewables, and the green is what's left. It's still a lot, but you see the pattern, yeah? And that is one of the big challenges for a future system. We're not there yet, 90%, and I believe there will be a lot of things happening until we get there. But the basic issue for CHP, where do I place my power plant in that pattern? And if I expect these things really to happen, it doesn't have to be 90%, 60% is already enough. Yeah? It reduces your operating hour, maybe, or you find a different business model. Yeah? So yeah, okay, I'm going to skip this, just shows you the same thing in different words. And this is also something for this is what we did. We were asked, well, you want to give public money to CHP power plant because you believe it is flexible, it is efficient, and we're saving CO2 with it. But please prove to us that you don't push out renewables. And so we asked our researchers, please show out, is there, how many renewables are on the grid when a standard CHP unit is running? And the left chart is for a comparison with a standard district heating network and photovoltaic solar input. On the right-hand side, you see the one for wind. And this, if you have 100%, if the district heating system is at 100% of its capacity, you have so many. The dots is the feed-in of photovoltaic, and there it is of wind. And this looks very complicated. The bottom line is, especially district heating, CHP and renewables fairly harmonized because photovoltaic solar is mostly relevant in summer times. Yeah, it doesn't surprise. And in the winter, where district heating systems do play out their advantages, you don't have sun at all in Germany almost, and you also don't have so much wind. If you have a close look at the dots for wind, you see it's getting closer there because you also have some storms in the winter. Yeah, it's getting there. So that's what we did for the CHP Act. Yeah. So what are the reactions of the utilities of in Germany? The district heating systems are mostly in the hand of 10 to 15 big municipalities which own their utilities and who, of course, are thinking about strategies to cope with that situation. Now, so you have the baseline. The key word is always flexibility. How do we get along with the renewables, and how can we make a business case out of it? Now you have the usual situation that CHP unit is running. It's not too windy, there's not too much sun. The heat from the CHP unit just goes to the end user, and everything is, and the power is fed into the grid. Everything is fine. Now they added two new elements to the system, which is mostly the heat storage system and an electric boiler, which is really for the very future. And they say with these two elements, a heat storage and an electric boiler, we can cope with flexibility and intermittent renewables. Because they say if you have, this is now the base case for the future approach, the CHP unit is not only feeding the demand of their customers, but it's only storing a little bit heat in a heat storage system. Heat storage is nothing else, just a big cup, which is very good isolated. Yeah? And they have been built in the past years by the big municipalities. Not to say in large numbers, but they are real, this is actually happening. They're using that, and I'm going to explain you why. Whoops, okay. Yeah, so now you have lots of sun and lots of wind, and so the grid, how does this go on here? Okay. Okay, this is a full picture. Yeah. So if there's a lot of renewables in the feeding electricity in the grid, so the grid is a little bit blocked. Yeah? The CHP unit is not supposed to feed so much electricity in there because it is likely to push out renewable energy. Now, at the same time, the CHP unit always has to take care of their heat customers, yeah, because they are not supposed to sit in cold, dark rooms. So they use a heat storage system and feed it to their customers. If there is even a surplus of renewable energy in the grid, that can be used to heat up water, which actually for technicians, for engineers, it's a terrible thing to do because electricity is the highest form of energy. And if you use it to heat up water, it's not efficient, but it is surplus energy, which would have been thrown away otherwise. And that is one idea that is really advocated by the utilities now. They say the keyword is power to heat. Use this surplus renewable energy, and we can put it, use an electric boiler and actually put it in the heat storage system, and heat can be stored for a longer time. It's different than electricity, which has to be converted in something and reconverted, and we use that. So we are able to cope with the situation with a lot of renewables in the grid by using electric boilers and heat storage systems. Yes?
Wouldn't there be a role here for electrical energy storage?
Yeah, electric. You mean batteries or?
Batteries.
Yeah. That's about storage system. There's a big discussion in Germany going on. Actually, about any storage, the basic thing is you have to see what kind of energy, electric energy, will be stored in there. And actually, the position of the government is it's too soon to think about that, because up till now, with only 32%, you have still almost 70% of conventional energy produced with coal and gas, with a lot of losses, which has to be converted into a battery and reconverted into the grid. So you have a lot of losses there. So it's not, from energy point of view, efficient to use these kind of storage systems. Same goes, of course, for heat systems. But this is a little bit what the utilities say they would use in the future if the system is so big, we have such a high share of renewables, that there is actually a surplus. Yeah? The big question would be who decides upon that? Yeah? And who decides, is it really a surplus? The most efficient way to use electricity is right there, in the same second that it is produced. So storage and converting it into something else always goes with losses. But if you have these surplus situations, that might be a way to use it. And power to heat is much cheaper than batteries. Actually, that is a technique that's older than 100 years old. Put a boiler into the water, plug it into the net, and wait until it gets hot. And actually, in Germany, the big utilities in Berlin, Nuremberg, smaller ones in the east, where you have a lot of district heating system, they are building these large thermal tanks, thermal tanks. Yeah, they're very big. I should have brought a picture of that. And what they actually do is they run their CHP unit during the week, where they have the highest demand, and they shut it down for the weekend, where the industry goes out. And as they still have to produce heat for their customers, they use the tank. Yeah. And for them, it's a way to get away from the very low electricity prices on the electricity market. As you might know, renewables do have an impact on wholesale market prices and bring them down very strongly. And the utilities, they don't want to have their CHP unit running on the weekend where they burn money. So they said, we rather do it under the week, where we can even have more flexibilities there and get in when we have high prices. We don't have the demand of heat. What we see at the electricity markets, we have high prices, so we have the CHP unit running and put the heat into the storage system and shut it down when we have low prices at the wholesale market. Now that's a little bit what the idea is. And these electric boilers, some of them do already have these electric boilers integrated, but we don't have so many surpluses in the system. If we have a renewable surplus in the German system, it's due to a lack of grid expansion. So we have bottlenecks in the north, and from a system perspective, it would not be good to invent a storage solution while we're about to build a new, bigger, more capacity, bring more capacity into the grid. And they use these electric boilers now for balancing markets, negative balancing energy. And as you might expect, the prices for balancing energy dropped. Everybody does that you have a lot of supply of that, and the prices will drop. But these are some business models for the utilities that are coping with these this revolutionary process in Energiewende. Okay, there were more fancy stuff in there. Yeah, there are even more strategies for the utilities, but which are not so important and are more on the research and development side, but it is deployed in some parts. Some of the municipalities use heat pumps at a larger scale. Some, as I said, Munich is using geothermal heat. I didn't find a good picture for solar thermal panels on rooftop, for example, but also on garbage dumps on sites like that. Problem with solar thermal is Germany does not have very much sun in the first place. Second is you need a lot of space, and the space is used rather for photovoltaic electric systems than for geothermal, which are more expensive. But there are some pilot projects in that. And this one up there is an electric heating system. I just found a German picture on that. In the Ruhr area where I came from, a very heavily industrialized, historically industrial center, we had these electric heating systems, which are up to just a couple of years ago were completely out of date, which were used to fed by the electricity from the large coal power plants. And in new times, these electrics up to 5 million end users, I think. That's a fairly big number. It can be used to take surplus renewable energy from the grid. Yeah. Okay, I hurry up. So just a brief overlook on CHP policy. We have different measures in place to ensure that new houses and modernized houses have a certain level. CHP can use to attain these standards there. We have a Renewable Heat Act, which obliges the owners of new houses to use as much renewable heat as they can. But there's an exemption for CHP because that also helps to deploy more CHP because CHP is regarded as most efficient heating system. We have the Renewable Energy Act, the famous EEG. There's a feed-in tariff which also used to contain a feed-in tariff for CHP using biomass as a fuel, which has been cut down very, very strongly in the 2 years ago because it was so expensive. So we had it's now under discussion again. Yeah. And then we have the CHP Act, which is the most important act. It's a feed-in tariff. It's a top-up on the market price. So you say the operator gets the market price, and we will pay him for every generated kilowatt hour a top-up of used to be 1.8 cent the kilowatt hour for a limited time over 30,000 operating hours, and after that it's a full stop. Yeah. We added new elements which are investment grants, a classical investment grant, 30% of the investment sum for new heat pipes, and a new element which supports flexibility are investment grants for heat storage systems. Last year we had this big discussion, as I said, and actually CHP was regarded as one tool that how we can obtain our very ambitious national goals. And we came up with a compromise, actually. The Parliament agreed to boost the budget for support from 750 million a year to 1.5 billion a year, which is pretty good. But they said you have to focus it more on flexibility, and that goes along with a focus on public CHP and district heating. We introduced a surcharge for existing gas. Usually it was the deal was you build a new CHP power plant and you get this support for 30,000 operating hours, and after that you're off to the market. You have to take care of it yourself. And now we took again in gas-powered CHP power plants because the decline electricity market prices was so hard that their business cases were ailing. And in Germany, in the last 15 years or 7-8 years ago, a lot of municipalities had invested in high standard CCGT combined heat and power plants, and the business cases were very bad. So they put a lot of pressure on getting these already existing power plants into the feed-in tariff again, and the compromise what we get them on board for 4 years. They don't get the full premium, not 30,000 operating hours, but just 16,000, I think, was at the end. And we believe that in 4 years the market will look differently, and then we see again. Yeah. And we get a lot of other elements on there. So the last slide, I hope I'm on track here, is on our targets. The targets, we had a very ambitious target which said we should obtain 150 terawatt hours of CHP generated electricity in 2020. It was obvious that we are not going to attain that. But there's also that kind of skepticism that I told you about if CHP really fits into the system. And the compromise was you will, a little bit will fit anyhow. Yeah, so we adapted the goals to 120 terawatt hours. We're around 100 now, so there's room for growth and for modernization. But due to the fact that there was some skepticism and that also the means, the 1.5 million, would have not been enough to boost it more than that, we reduced it to that. Yeah. Okay, thank you. I talked too long.
We do have time for questions. There are a number of questions, I would think. Can you say who you are?
I'm Darrell Thayer, a local educator in renewable energy. How do you plan on including biofuels into your CHP? Can you do a gasification and then use a turbine, or do you have to go through just a ranking cycle?
No, ranking cycle is very special and very rare, but no, I mean, we have actually all sorts of, for all kind of applications for biomass, burning wood, pellets, systems. We have a feed-in tariff and gas-fired motors, mostly. We have feed-in tariffs. Actually, what I said 2 years ago, they put a stop on this process of building new biomass CHP units because it was so costly. Now there's a law in Parliament trying to reinforce that, but it was really one of the most costly part, these biomass CHP units.
Hi, Will Nissen with Fresh Energy. You mentioned Munich's 100% carbon-free goal, and that biomass CHP will play a part in that. Did the city or the country do any calculations or rules on what type of biomass fits in the carbon cycle impact calculation?
I actually can't really tell you very much about that. I think for Munich, this strategy they announced, I think, 1.5 or 2 years ago, and it was the go for investment into drilling. Yeah, and I think the other parts will come later on. They still have one coal-fired power plant that is to be shut down in a couple of years, but they have to find a different solution for that. Will it be gas, or will geothermal be enough to get enough heat in the system? And at the very end, what they will use for biomass CHP, I don't know.
Hello again, Tim Rudnicki. I work with biofuel producers in Minnesota. I guess as I listen to your presentation here, I get the picture that it's combined heat and power, and it's primarily a large traditional generator, and then the waste heat, so to speak, goes to district heat and the like. Are there any examples in Germany where a specific industrial sector might be doing its own version of CHP? And I know you referenced the autos.
They are doing. I mean, chemistry, Bayer, BASF, they have huge CHP units because they need the process steam. and they actually need that, and for them it's the most efficient way. Here the focus was a little bit more on the district heating part, because the questions that has been asked or put forward to us as administration from policy side was, what kind of system fits in the longer run or in the medium run to a system with a lot of renewable energy. But on the other side, the question, which from my personal opinion has not completely been answered, how do we deal with industry? I mentioned that we will have, as long as we have this energy-intensive energy in Germany, which is at the core of our business model as a country, we need this heat. And up till now, nobody came up with an idea how to produce it more efficiently other than with a CHP gas-fired unit. Yeah, actually the business case for CHP units in industry looks quite good. It's not the same case for public, because industry is using their electricity themselves, and they can produce them at very competitive costs. That's why they're doing it anyhow. Yeah? And so for the time being, our analysis was they don't need any funding from us, which they don't like, of course. But we had really broad analysis for that. We've been discussing that over and over again. Electricity prices in Germany are quite high compared to United States, and they can save a lot of euros by producing it themselves. And yeah, if you call it that, yeah. I mean, they always ask, where's the flexibility in industry? Yeah, and these are very future plans. When you have 90% renewables and you have all this surplus renewable energy, why don't you take this power into your system? They say, wait, we're not there yet, and I have to take care of my process here, and process steam is the most important thing. I'm not going to switch like that. But maybe these are issues to think about in the future, and it would have to be an economically viable case, of course. Otherwise, you can't tell them just use that energy. And, yeah.
Hi, Ellen Anderson again, Energy Transition Lab at the university. I mentioned that there was this stakeholder process here in Minnesota over the last couple of years that looked at identifying barriers to combined heat and power in Minnesota. And a couple of the ones that stand out that I recall from reading all this is, number one, when you're a self-generator, if you're a company or a industrial facility and you're trying to do combined heat and power, you have to pay standby rates to the local utility, which is basically a charge to have a grid charge, basically, to enable that electric grid will be there as a backup if you ever need it, if your system's down. And that is a big financial barrier. Another barrier that we face here is the fact that thermal energy and electrical energy are two siloed systems that are in very different policy dimensions. They have different participants, different rules, different regulator, well, sometimes the same regulators, but so that's a barrier as well. And for example, we have incentives for renewable electricity or for biomass electricity, but not for thermal renewable energy. And so I'm wondering if you would want to comment on sort of have you experienced any of those kinds of barriers or difficulties, or how have you overcome those?
Yeah. I mean, in Germany, there's also a big debate about auto-generators, and I think it's a little bit, you can compare to the debate that you see here about net metering sometimes. What is the value of being able to use the grid at a certain time? They come in these charges that you mentioned. We have the same there. Actually, as in Germany, we put the cost of the renewable scheme is a levy which is put on electricity prices, so you can get away from that by auto-generating. So there was a big discussion about that, and 2 years ago the parliament decided to tax them also, the auto-generators, to have them pay also for renewables, because it was seen as not justified that they don't contribute to the whole process. And And this is it's a spiral, you know, because the more we keep funding renewables, the costs get higher, and some get out of the system. Well, that the politicians said we can't actually allow that. And yeah, barriers, as we mentioned before, there are always some barriers. But at the very end, I believe the systems are working. If you look at the slides with this growing renewables, they found a way, figured out a way to get through it. There's red tape, of course, like everywhere, but on the other hand, you have to acknowledge that there are some standards that have to be met by renewables or CHP units when they feed into a public grid that has to be kept in balance at every second time.
Final question?
We got a question back here. Jerome Malmquist from the university here. Auto-generate, define that. What do you mean by auto-generate?
No, they produce their own heat and electricity. They consume the electricity they produce on site. They don't feed it into the grid.
So everything's behind the meters, which are being, and they
what?
generate anytime they want then too, right?
Yeah.
And it's all behind the meter.
It depends where you put the meter, yeah.
Yeah, we know all about that.
No, but they don't get up into the grid. Yeah, exactly.
Do you have a final comment?
Yeah, just maybe one final point as a bottom line from the discussion last year about flexibility and how does it fit in the future system as regards district heating system. Actually, one bottom line was that the real asset there is the district heating network, because how do you think, as we think we go ahead in a world where the most of the population is living in dense agglomeration with a lot of people, how do you get the heat and cooling also into these big housing projects? If you don't believe that we have the zero energy standard house in the existing housing in 2 years, you must find a solution to bring heat and cooling there. And actually the asset to do that in a very efficient way are the existing or new to be built district heating networks. And how you fuel them, you can look later on that. I'm sure we will see different kinds of solutions, but the solutions at hand are motors and turbines. Yeah. And if you put some biomass in it, it's great.
Mr. Acker, I want to thank you for the Institute on the Environment at the University of Minnesota for being here, making this your first stop. I'm sure there are going to be many more as we call on you to explain different aspects of Germany's renewable energy transition. Let's give him a round of applause.
Thank you.
And I do know that he indicated he's very willing to entertain individual questions. So please make use of the opportunity you have. Thank you for coming.